Okay, so let's dive into this research on large language models, LLMs. The ones that can interact with the world through API calls. You seem really interested in how these LLMs handle nested API sequences.
Yeah, that's where things get really complex, like really interesting. This paper, NESTFUL, a benchmark for evaluating LLMs on nested sequences of API calls, kind of highlights this gap, where even advanced models struggle with this kind of intricate reasoning.
So it's like more than just, hey, AI, make a pizza.
Yeah, right.
It's like breaking it down.
Yeah.
Preheat oven to 400 degrees, chop vegetables, all these API calls in a specific order. It matters.
Exactly. And what's kind of surprising is that even these LLMs with like billions of parameters and trained on massive data sets, they still haven't mastered this.
Really?
Yeah, the researchers tested 15 state-of-the-art models and none of them consistently nailed it. The best one only had like a 25% full sequence accuracy.
Wow, 25%. That's surprising considering how well they do in other areas. What do you think causes this?
Well, traditional LLM training focuses on generating text that makes sense, not on the logic and data dependencies in these API sequences. It's like teaching chess by just showing pictures of chessboards.
They might see the pieces, but not the rules, the strategy.
Exactly. And to test this, they created this NESTFUL benchmark. They used the MathQA dataset, math word problems, and the StanCodingInstructions dataset, which has more general coding tasks.
For MathQA, did they just throw equations at these LLMs?
Not really, no. They turned those word problems into API call sequences. Like, if you execute them right, you solve the problem.
Yeah.
Like, John buys 3 apples for $2 each. How much change from a $10 bill?
Gotcha. So they need multiply for total cost, then subtract for the change.
Precisely. And they went beyond just providing those calls. They gave detailed specs for each API, inputs, outputs, data types, like a super specific recipe.
So the LLMs couldn't just guess.
Right. They had to generate the right sequence, format, data types, everything.
Wow. What about StanCodingInstructions? What did that involve?
That was more about general programming functions, like sorting arrays, rotating strings, things like that. But again, you needed that nested sequence to get to the answer.
So really pushing them beyond just generating text into this world of data and logic.
Yeah, and it's a bit of a wake-up call. We've made huge strides, but we've got a ways to go for true intelligent agents that can solve real problems.
It's interesting, this whole data type thing keeps coming up. How does that trip up LLMs?
Well, think about it. In language, we can be flexible with meaning, but in programming, it's strict. An integer is an integer, not just a word representing it. And that rigidity seems to be where they struggle. They're used to the fluidity of language, not the strictness.
So even though they've seen tons of data, they haven't grasped the nuances of how data types work in programming, especially in these nested sequences, where the output of one call becomes the input for the next.
Exactly, and that's where it gets really tricky. The paper also highlights variable assignment, referencing output parameters.
So keeping track of which variable is which and how they relate.
Yes, and that's crucial because if an LLM can't accurately assign and reference, the whole sequence breaks down.
And I imagine that's even worse with parallel function calls.
Absolutely. It gets much more complex, and we see that reflected in the performance drop when they face these parallel calls.
So we've got data types, variable assignment. Are there any other big hurdles for LLMs with these nested calls?
Yeah, one more that's really interesting is implicit API calls, where the user's query doesn't explicitly say what tasks need specific APIs.
Can you give an example?
Like, imagine a user asking, "What's the weather in Paris?" To answer that, the LLM needs to understand it needs to call a weather API and even which one's best for that query.
So it's not just following instructions, but understanding the intent behind them.
Yeah, filling in those gaps, and that requires a level of understanding and reasoning that's still developing.
This is making me rethink how we approach AI development. It's more than bigger models, more data.
Yeah.
It's about teaching them to think logically,
Absolutely.
structurally.
I agree. This paper is a good reminder that we need to be more intentional with training if we want them to really interact with the world.
Yeah, this has been really eye-opening. But before we jump into solutions, let's take a step back and look at the evaluation metrics they used in this study.
Yeah, that's a good point. Understanding how they assess these models will give us a clearer picture of their strengths and weaknesses.
Exactly. So let's break down those metrics and see what they tell us about LLMs and these nested sequences.
Yeah, so to really get into how they measured these LLMs on the NESTFUL benchmark, they used a bunch of different metrics, kind of like shining light from different angles.
Okay, so let's start with the most obvious one, accuracy. What does that even mean with these API calls?
Well, they looked at two types, actually. You've got
Oh,
partial sequence accuracy and then full sequence accuracy. So partial accuracy, that's like getting partial credit on a test.
hmm.
You know, it measures how many individual calls within the sequence the LLM got right, even if the order was off.
Okay, and full accuracy is more strict.
Yeah, full accuracy only counts if the LLM nails the entire sequence, every call in the exact right order. Remember that 25% we talked about?
Yeah.
That's the highest full sequence accuracy any model managed to get.
Wow.
It really shows how hard it is for them to put it all together, even if they get the individual pieces.
Makes sense. So what other metrics did they use?
They also looked at what they call the F1 score, specifically for function and parameter names.
Okay.
So this measures how well the LLM can pick out and actually use the right functions and parameters, the nuts and bolts for each API call.
So not just knowing what multiply means, but knowing how to write it out correctly in code with the right inputs and all that.
Exactly. You got to be precise with APIs for them to work.
Yeah, one tiny error could mess up everything, right?
Oh, yeah, absolutely. And that's why this F1 score is so important. It shows how well they can actually talk to those APIs.
Okay, so we've got accuracy, F1 score.
Mm.
Anything else they looked at?
This last one is really cool. It's called win rate. It's kind of different because it goes beyond just looking at individual sequences and actually pits these LLMs against each other.
Competitive, huh?
Yeah, they basically set up a tournament where different LLMs went head-to-head on the same tasks, kind of like a coding competition.
Oh, I see. So it tests their overall strategy, not just their ability to solve one problem in isolation.
You got it. And this is a more realistic test, right?
Yeah.
Because in the real world, they might need to adapt, compete with other systems.
Yeah, that's a good point. So how did they do in this tournament? Any clear champions?
Well, here's the thing. Bigger models generally did better, but it wasn't a guaranteed win.
Interesting.
Some of the smaller models, especially those fine-tuned for function calling, they actually beat the big guys on certain tasks.
So it's not just about brute force. You need the right skills, the right strategy.
Exactly. And that's encouraging because it means we might not need to build ever larger models, but instead focus on smarter training techniques.
I see. This is making me think bigger, you know? What did these results tell us about where AI is headed?
Yeah, I think it shows that while we're amazing at text and language, we're still figuring out how to build AI that understands the world the way we do, interacts with it in that way.
So this nested API challenge, it's not just technical, it's kind of philosophical, right? Getting at the core of what intelligence is.
Yeah, absolutely. And it's a question that's going to drive AI research for a long time.
Absolutely. Well, on that note, let's move on to some potential solutions. I'm really interested in this idea of teaching LLMs to visualize those API dependencies.
Yeah, that's a good one. It plays their strength in visual processing,
Right, instead of just code, we give them flowcharts, diagrams to show the data flow, how the calls connect.
like a roadmap to navigate that complexity.
But how do we actually train them to understand those visuals?
Well, we could start with datasets that pair up those API sequences with their flowcharts, side by side. The LLM learns to map between the two, builds that visual understanding.
I see. And once they get it, we can test them on totally new sequences, right?
Exactly. Give them a flowchart and see if they can write the code or even spot errors in the visual itself.
That's a good test. It's not just pattern matching anymore. It's true understanding.
Yeah, and imagine the possibilities. LLMs that not only execute those calls, but design entire workflows based on visual specs.
Like AI architects, building and managing complex systems with visuals that both humans and machines understand.
Precisely, a vision worth pursuing, though, of course, there'd be challenges.
Yeah, like how to represent those complex relationships visually in a way that captures everything. How to design the right training data.
For sure. But challenges are worth facing. The payoff could be huge.
Well said. Now, you've been thinking about this, right?
Yeah.
Any other novel notions that have come to mind?
Thinking about these visual representations, it's a cool idea, but what if we looked at how humans learn these complex sequences? Like we break big tasks down, right?
Yes.
Smaller chunks. Practice, practice, practice until we get it. Could we do that with LLMs and API calls?
Like learning a song. You don't
Right.
just play the whole thing perfectly right away.
Exactly. You practice scales, chords, little bits before putting it all together.
Right.
So instead of giving the LLM this huge API sequence all at once, we create like a curriculum, Start simple, 2, 3 steps, then get more complex as they improve.
Like scaffolding, you support them early on, then let go as they learn.
Exactly. And think about it. This could make learning faster, right? They focus on those small chunks, get better feedback, spot errors quicker.
Yeah, and maybe they generalize better too. If they've mastered all these little sequences, they might handle new combinations better.
That's the idea. And it could make training more robust,
Hmm.
gradually increasing the complexity so they don't get overwhelmed, don't get stuck.
This is making me see the connections between how we learn and how machines learn.
Right. It's fascinating. And we can combine this with the visuals, show them the flowchart for a small chunk, they practice, then we reveal more as they go.
Like a guided tour of those API calls, starting simple, then uncovering more and more.
And this gradual thing, it could help with another problem, interpretability.
Ah, the black box problem, right. We don't always know why they make the choices they do.
Exactly, especially with these complex sequences. But if we break it down, give them visuals along the way, we might get more insight.
Boy.
See where they struggle on the flowchart, see patterns in their errors, maybe even build new debugging tools just for this.
It's like we can peek inside their thinking, see how they approach it.
And that transparency could be huge for trust, right? As we use them in more real-world stuff where the stakes are higher.
Yeah, that makes sense. It's amazing how these technical details tie into bigger questions about intelligence, learning, trust.
It really is. We're still early on in figuring all this out, but research like this NESTFUL paper, it pushes us forward, helps us see what's possible.
It's been a great deep dive, really eye-opening. It feels like we just scratched the surface, though.
Oh, definitely. And to everyone listening, keep exploring these ideas, keep asking questions, keep that conversation going. It's important.
Absolutely. Thanks for joining us, and until next time, keep learning, keep questioning, keep diving deep.